Hey, ladies and gentlemen, boys and girls, it's the Burma Nation here. We're checking in for you guys. We're going to talk about 2-3 today. 2-3 is all about solving multi-step equations. We're just building upon what we talked about in lesson 2-2. So here's the biggest part of how this stuff works out. In chapter 1, we talked about the order of operations. That's PEMDAS stuff. If we are solving equations that have more than one step, our goal is to undo the order of operations. So if you think about PEMDAS, the opposite order of that would look like this. Ooh, that's really good handwriting. SADMAP? We can go with SADMAP. So SADMAP would be a way that we can keep ourselves kind of using like the order of operations to check which problem we should undo first. Okay, so in example number 1 here, let's go in red. That's everyone's second favorite color. Blue is my first one due to my wife's eyes. That's really corny. Don't tell anyone else. It's our little secret. So we're going to write down the problem, and the steps here are going to be to undo the order of operations. So we have multiplication happening to the W and then addition. So the opposite of doing multiplication first and then adding, we would subtract first. So we're subtracting following the golden rules of algebra, which is to whatever you do to the left side, you got to do to the right side and vice versa. And we get ourselves this answer. This makes 0. So we have 2w is equal to a negative 8. And then we'll go ahead and solve that specific problem. And to solve that problem, we will again undo what's happening to the w using inverse operations. So we will, instead of multiply, we will divide both sides by that same 2. 2 divided by 2 is 1w, so I'm going to write down 1w. And a negative 8 divided by 2 is a negative 4. And just like in lesson 2-2, we could plug this back in to check to make sure it's correct. 2 times that negative 4 is a negative 8. Negative 8 plus 11 does make 3. So I know that I've done things correctly. So double check those things. It's a really good skill to keep track of in your brains. Now in example 2, we have k plus 9. All of that stuff is over 12 is equal to a negative 2. Now there's something going on with this problem. There's implied parentheses. Ooh, look at that cursor go. These are called implied parentheses. They're implied because if you remember when we talked about doing the order of operations in chapter 1, we just told you that you have to do all the stuff on the top and all the stuff on the bottom before you can look to simplify or divide top to bottom. So we're going to get rid of this division first, even though the SADMAP, the reverse order of the order of operations, would tell you to get rid of the addition first. So we're going to take this whole left side and this whole right side, and we're going to multiply by 12. When we multiply by 12 and divide by 12, it gets us to remove the 12s. So we're left with just a k plus 9 on the left side, and then we have this negative 24 on the right side. So our last step would be probably the easiest one, minus 9. We find out that k is equal to a negative 33. And again, you'd want to double check to make sure that you're doing things correctly. Now, word problems tend to be the thing that you guys, as students, dislike the most. I, too, when I was a youngster, disliked the word problems as well. They were just more work. And realistically, folks, it tells us what to do here. So as much as I agree with you, I disagree with you now that I'm older and wiser and uglier. For sure, the uglier part. So Susan, she had a $10 coupon for a purchase of any item. She bought a coat that was on sale for 1/2 of its original price. After using the coupon, Susan paid $125 for the coat before taxes. What was the original price? Write and solve an equation. Well, I would imagine, folks, that 1/2 the price should probably be 1/2 times P being the price. And then she had a $10 coupon, so we could just subtract that $10 too. And since the price that she paid was $125, sounds to me like we just made ourselves the equation, because that's exactly what they just told us to do. In order for us to solve this, we would do what we did on the previous problems. We're going to get rid of the minus 10 first, because that is undoing the order of operations. And we have ourselves, let's see, plus 125. So half of a p is equal to 135. And so just like we talked about again in the previous lesson, we're going to divide by a fraction, which is the exact same thing as multiplying by the reciprocal. So this is me dividing by the fraction. And anyways, just logically thinking, half of a p, if we want the whole variable p, the whole price, we're going to find it that we do 135 times 2. So the whole price is equal to $270. And that seems like an awfully expensive coat. I don't think I would want to buy that one. What is it made out of? Gold? All right, other ideas here. Consecutive integers. Now this is an idea that's a little bit more abstract. So you're probably going to want to write this stuff down for sure. Consecutive integers can be represented by the following sequence: n, n plus 1, n plus 2. The way to make sense of this, folks, is n could be any number. But if we're talking about consecutive, that means that if n was 1, the next consecutive number would be 2, and then 3. So if this was a 1, to get to the next one, we had to add 1 to it. To get to the third one, we'd had to add 2 to the original. So that's where this n, n plus 1, n plus 2 is coming from. And with the same kind of logical thinking, consecutive even integers. So if my first even number was this negative 2, a negative 2, to get to the next even number, we had to add 2 more to it. So that's where we have n, n plus 2, n plus 4. Because we're adding to the original if this is n. So we added 2 more to find the next even, 2 more from that one, but 4 from the original n to get the next even. And it's the exact same idea with odds. Because if the first one was n, to get to the next odd number, we would add 2. To get to the next odd one, we would have added 4 from the original. So remember that consecutive even, consecutive odd, they're going to be represented by the same n, n plus 2, n plus 4. But if we're talking about just consecutive numbers, we're just increasing by 1 every time. All right, so here's a problem that looks like those consecutive integer problems. It says, find 3 consecutive odd numbers with a sum of 57. So if the first number is n, and the second number is n plus 2, because it's consecutive odd, and then the third number is n plus 4, we find ourselves having a total of 57, it said, because it says sum we're adding. So this is a combining like terms type of a problem. I have 1, 2, 3 n's, so I have 3 n's written down, and then a 2 plus a 4 makes a plus 6. So here's my multi-step equation now. All I have to do is solve this by subtracting 6 from both sides, getting 3n is equal to 51, then dividing by that 3, dividing by 3, and finding out that n is equal to 17. So if n is 17, my first odd number, my second odd number would have been 19, and my third odd number would have been 21. So these are my 3 consecutive odd integers. All right, folks, that's what this lesson's all about, is you being able to put numbers into equations and solve them appropriately. This is the Berman Nation. We're signing off. Until next time.